Right now we're going to look at motion maps. Essentially what motion maps are a way to represent motion using dots and arrows. They're fairly straightforward in the sense that the arrows point in the direction the object is moving. It just takes a little bit of getting used to draw them. Why do we use them? It's another way to represent motion. We can use motion maps, we can use graphs, and then we can also use equations and word problems. So what do motion maps look like? It's going to start with a line. This line will have hash marks, evenly spaced, and those will represent distance increments. So for simplicity, let's say this is 0 meters. So this would be 1, 2, 3, 4, 5, 6. Doesn't have to be exact, but you do want to show that they look about even. Next, you're going to use a dot to represent 1 second. The main thing to remember here is that your very first dot will be 0 seconds. So let's say at 0 seconds I'm at 0 meters. I'm going to use a dot. 0 seconds, let's say in 1 second I travel 1 meter. So at 1 second I'm at 1 meter. 2 seconds, 2 meters. 3, 3, 4, 4, 5, 5, 6, 6. Arrows are going to point in the direction of the motion. So I'm going to move to the right. I'm increasing by 1 meter every second, and the length of the arrow would indicate how fast. So if I'm increasing my motion by 1 meter every second, that would give me a speed of 1 meter per second. Since we're going to the right, the arrows show that this is a velocity. Remember, velocity has direction, speed does not. So I want all of my arrows to be 1 meter long. So this motion map shows an object moving at 1 meter per second to the right at a constant velocity. Since the arrows are not changing their length, not changing their size, it means the object is moving at the same speed the entire time. So this would be a motion map with constant velocity to the right. Now let's just look at a motion map that goes the other way. We're still going to draw it like this. We want our hash marks to show different increments. And just to show that the increments really don't matter, let's make each of these 2 meters. So 2, 4, 6, 8, 10. If I have an object that, say, starts at 10 and goes 4 meters to the left every second, my next one would be at 6 and then at 2. And I would show my arrows pointing to the left to show that the direction is the left. So with the seconds, this starts at 0 seconds here, 1 second here, 2 seconds here. So 0, 1, 2 seconds, even though you have 3 dots, the object is moving -4 meters per second. Now let's say we have an object that changes direction. I'm going to do my best. These aren't always even, but as long as they're generally evenly spaced. So let's do 0 meters. We'll make this 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to have an object. We'll start 0 meters at 0 seconds. Let's say it moves 2 meters per second for 2 seconds. So 0 to 2 in 1 second, 2 to 4 in the next second, so constant speed. Let's say it then stops for 3 seconds. That means it's going to be at 4 meters for 3 seconds. So here's 1 second, 2 seconds, 3 seconds that it stopped. And then it moves to the left now at -1 meter per second. So it goes from 4 to 3, from 3 to 2, from 2 to 1, and let's say it goes back to 0. Total time that this all takes: 0 seconds, 1, 2, 3, 4, 5, 6, 7, 8, 9 seconds. How would we describe this motion? The object moved at 2 meters per second for 2 seconds. It stopped for 1, 2, 3 seconds and moved at -1 meter per second for 1, 2, 3, 4 seconds. Main thing to remember with these dots is that the spaces in between the dots show the time and then the arrows show the direction. If I had drawn my increments better, the arrows here would be the same length. If you'd like to see more motion map examples, I will post another video with a few more. Otherwise, if you feel okay, make sure you have notes and we'll work on this more in class.